In this video, let's take a look at the characteristics of an ellipse. If you recall, an ellipse is very similar to a circle. If we think of what a circle is made of, a circle has the equation x squared plus y squared equals r squared, and here in our diagram we have a circle. We said that when it came to the ellipse, it kind of like was a stretched out circle. We took that one focus point and then we brought it into two other focus points, right? We stretched that focus point out. And when we did that, what we ended up also doing was we kind of stretched our circle. We didn't change anything with the y values. The y values stayed the same. But what you end up doing is you kind of stretch your circle horizontally, as you can kind of see here, right? So the y values stay the same, but the x values are the parts that get stretched because these focus points ended up getting pulled apart. Now because of that, if you think about the equation of a circle, x squared plus y squared equals r squared, what we're really thinking about is this function got stretched horizontally. How do we tend to think about that? Well, you tend to think as a function that if it got stretched horizontally, you're kind of thinking about how that value of x gets multiplied by half. So basically what we're seeing here is that if you have a half there, it's kind of like saying, oh, well, we're going to have that half, or if it's being x squared, a half x squared plus y squared equals r squared. In a way, you're kind of saying, oh, that really becomes x squared over 4 plus y squared equals r squared. So that horizontal stretch becomes almost like the denominator of a new fraction, of a new equation, x squared over 4 plus y squared equals r squared. The same thing can be said for the y's. If you stretch it vertically, then it's going to affect the y's, and maybe you'll actually have something down here to show what that y will become. So, going now to our ellipse equations, what we're going to do is label all the parts of an ellipse, both horizontal and vertical, and see what kind of equation we can form. Now when it comes to an ellipse, you'll notice that there's always one longer side and one shorter side. In the case of a horizontal ellipse, what we see is that the longer side is the x-axis. This is what we call the major axis. And therefore, if that's the major axis, then the y-axis will represent the minor axis. Okay? Now, based on the points we see here, because the major axis is along the x-axis, we can actually define a couple of points here. We know that this is going to be our center. But more importantly, the point over to the left and to the right from the center, because it's along the major axis, will be called the vertex. Because you have two of them, they would be vertices for the plural form. Okay? Now the vertex is given the ordered pair a, 0, and likewise on the other side, negative a, 0. Along the minor axis, we have two other points, one right here and one right here. Because a along the major axis took the name vertex, these are actually called the covertex or covertices for plural. The covertex has the ordered pair 0, b, and also 0, negative b. Those are the covertices. And then the other 2 points that I had mentioned to you before, kind of like our focal points, our focus of the ellipse, it kind of dragged that center out. So we would have a point here and also a point here. We call these purple dots the focus, or the plural form of focus is foci. Some people say foci. Okay, so I'll call it foci though. Foci is the plural form of focus. And just like the vertex and covertex, the focus also has an ordered pair. We call it c, 0 and negative c, 0. Now, based on the ordered pairs that you see there, you can pretty much assume that the distance from the center to the vertex has a distance of a. The distance from the center to the covertex has a distance of b. And the distance from the center to the focus has a distance of c. Now likewise, it goes in all directions, so keep in mind whatever you do to the right side or up, or it also applies going left and down. Okay. Now in terms of the equation that we form, I'll write the equation now. We have the equation, keep in mind we have x squared plus y squared. It very closely resembles a circle, but as we saw in the previous slide, you're going to divide it over an a squared. Because x is along the major axis, it makes sense that the a is actually directly below the x. Okay, so x squared over a squared plus, since the y was the minor axis, we see that the b value is associated with the y's, so it'll be over b squared. And for all ellipses, we're always going to make it equal to 1. Okay, so unlike a circle, it doesn't have a radius anymore. This equation is always equal to 1. If you find that there is a number here, then you want to divide by that number to make sure this is a value of 1. Okay, so a couple things to note as we were labeling some of those parts. Keep in mind that the A is always attached with the major axis, which is the longer side. And we call that the vertex at each of those endpoints. The B value is always attached with the shorter side, with the minor axis. Okay, the shorter side. And we call that the covertex. And then lastly, if you actually need to find the focus, which you will, we have an equation to find the focus. It's going to look vaguely familiar and yet not familiar. This equation is built off of c squared equals a squared minus b squared. You might think, oh, that's Pythagorean theorem. But look a little bit more closely. We do have a minus there. It's not plus. Okay, so I know it does look like a Pythagorean theorem, but it is not. We're not going to prove that in this class. We're not going to prove this equation in this class. We're just going to simply use it. Okay. Let's now take a look at the vertical ellipse. Now, in terms of the parts, we can kind of classify it in the same way. If you recall, what we say is that the longer side represents the major axis. And so therefore, if this is the major axis, one thing we definitely know is that at each of those endpoints, those are going to be called the vertices or vertex for singular form. Okay, so the vertex now has a new ordered pair. Because it goes up and down along the y-axis, we now have a vertex at 0, a. Remember, a always attaches with the major axis. Okay, and the other vertex is going to be at 0, negative a. Now, if the major axis is the longer side, then you can assume that the shorter side is going to be called, the minor axis. If this is the minor axis, remember that these points on the left and right are now called the covertices. And this point here on the left is going to be now, remember it's using the b value, is going to be the ordered pair negative b, 0. And on the other vertex, this will be b, 0. Did I say vertex? I meant covertex. Keep in mind they're all coming from the center point. And also from the center point, we have another important point, which we classify as the focus. Remember, the focus is inside, it's within the ellipse, and they are of equal distances apart of each other from the center. So we have two foci. Oops, I spelled that in the plural form. And the focus, if you recall, has a length of c. So therefore, this focus is at the point 0, c, and this focus over here, down here, is at 0, negative c. It has a distance from center to focus of a distance of c. The center to the vertex, again, is a distance of a. And the distance from the center to the covertex is a distance of b, just like that. Now, we have a new equation as well. If before we had x squared plus y squared, x squared over a squared plus y squared over b squared equals 1, we're going to do the same thing with this ellipse. Keep in mind it does resemble a circle, so we stick with the x squared plus y squared. But now, if you look at the diagram, we'll notice that the a is actually attached with the vertical part, the y. So now we're going to have the a squared under the y squared. And you'll notice also the b is attached with the x values, So x squared over b squared. And again, all ellipses are always equal to 1. So that's our equation of a horizontal ellipse. And then this is our equation for a vertical ellipse. Oops, I'm sorry, I'm not writing it correctly. This was the horizontal ellipse. And this was a vertical ellipse. I apologize for that. Okay, and then the equation of the focus is always going to be the same form. No matter what type of ellipse you have, whether it's horizontal or vertical, you'll always use c squared equals a squared minus b squared. Okay, we'll stop there, and then in our next video, we'll take a look at some examples.